Okay, this is 4.4 greater than with a question mark. And this is a developing understanding task. So here's our situation. For each situation, you are given a mathematical statement. Like in this case, the statement is x equals 8. And two expressions beneath it. The two expressions would be x plus 5 or 3x plus 2. Number 1. Decide which of the two expressions is greater if the expressions are equal or if the relationship cannot be determined from the given statement, in this case x equals 8. So if they have told me that x equals 8 and they give me two expressions in terms of x plus 5 and then 3x plus 2, we should be able to do direct substitution to determine which expression is greater. So x equals 8. So take a look at the x plus 5 here. That's going to be now x is 8, so 8 plus 5. And what is it? 8 plus 5? 13. Now, if I do direct substitution for the second expression, 3 times x plus 2, where the x is 8, that's 3 times 8, 24, plus 2 more, that's 26. So which is greater, 26 or 13? The 26. So that tells me 3x plus 2 is greater than x plus 5. So let's write an equation or inequality that shows the answer. So let's just say 3x plus 2 is greater than, and this is the symbol for greater than right there. All right. Remember, your middle school teacher probably talked about this being the mouth of an alligator, and the alligator wants to eat the bigger dinner. So 3x plus 2 must be greater than x plus 5 because this alligator wants the 3x plus 2. All right, there we go. Now number 3, explain why your answer is correct. Okay, well, we found the answer was correct with direct substitution. So we use direct substitution and found that when x equals 8, 3x plus 2 is always greater than x plus 5. All right. And that should have been used right there, but I'll fix that later. Okay, so that must have been a warm-up problem because here's number 1 right here. Okay, so again, this stuff up here will never change. So we're going to be given a statement and two expressions, and then we will answer 1, 2, and 3. Number 1, to decide which of the two expressions is greater if the expressions are equal or if the relationship cannot be determined from the statement. So the statement is y is less than x. So if y is, and do you notice, remember, I could read this like this too. The alligator, x is greater than y. Or if you read it from left to right, this is y is less than x. Okay, so if y is less than x, think about this expression, x minus y. Well, y is a number smaller than x. So if I go x minus y, wouldn't that always give me a positive number for an answer? But if I go the other way, y minus x, or I go a smaller number minus a bigger number, that would always come out negative. All right, so x minus y, a positive number, is always greater than a negative number. So which is greater? X minus y. Now number 2, write an equation or inequality that shows your answer. So we just said x minus y is greater than y minus x. Great. Okay, now number 3, explain why your answer is correct. Well, why is this correct? Well, very simple. Oh, by the way, that check mark there, good. Any positive number will always be greater than any negative number, so this must be true. And there you go. First problem. Okay, second problem. Same instructions. The statement is, oh, look at this. 2x minus 3 is greater than 7. And they want to know which is greater, 5 or x. Wow. So, could we take this statement, which is an inequality, note greater than alligator, and just solve for x? So 2x minus 3 is greater than 7. Now you guys are really good at solving equations. Let's get really good at solving inequalities. So the first thing we need to get rid of is a minus 3. And the inverse of subtracting 3 is adding 3. So let's add 3 to both sides of this inequality. So we bring down the inequality symbol just like we would for an equation. And 2x minus 3 plus 3 is 2x. And on the right, 7 plus 3 is 10. So 2x is greater than 10. And now we need to undo this multiplication by 2. The inverse of multiplying by 2 is dividing by 2. So let's divide both sides by 2. Bring down the greater than. And 2x divided by 2, the 2's would cancel, leaving x is greater than 10 divided by 2, which is 5. So, hey, look at this. Which is greater, 5 or x? Well, we just said x is greater than 5. Answer is x. Okay? Write an equation or inequality that shows the answer. Hey, we have that already right here. Awesome. Now explain why your answer is correct. So how do we know we're correct? Well, we took the given statement, which was an inequality, and we solved for x. So we solved our first inequality and determined x is greater than 5. Smiley face. Right on. Number 3. Statement 10 minus 2x is less than 6. So this is just like the last problem. Okay, let's take this inequality and solve for x. Okay, so 10 minus 2x is less than 6. Well, if we're going to isolate this x, we'd better get rid of this 10 right here. So that's a positive 10. So to get rid of that, we're going to subtract 10 from both sides. Now we bring down the inequality, and 10 minus 10 is 0, and we're left with negative 2x is less than, and 6 minus 10 would be negative 4. And now, one more step. We need to undo multiplication by negative 2. What's the inverse of multiplication? Division. Let's divide both sides by negative 2. Now, very important rule when you're solving an inequality. Whenever you multiply or divide both sides by a negative number, you must reverse the orientation of your inequality symbol, which in layman's term means we flip it. So this less than becomes greater than. And now on the left, the negative 2's cancel, so x is greater than, and a negative over a negative is positive. 4 divided by 2, 2. X is greater than 2. So look at this, which is greater, x or 2? We've done it again. X is greater than 2. There's number 1. Number 2. Write an equation or inequality that shows the answer. Well, we already did that too. X is greater than 2. There it is. Explain why your answer is correct. Same thing. We took the given inequality and we solved for x. So we solved our second inequality and determined x is greater than 2. Smiley face again. I'm liking this. Number 4. Another inequality. Awesome. Well, this is great. I like these. So let's go ahead and solve the inequality for x. And this is less than or equal to. Very cool. So 4x is less than or equal to 0. So we need to isolate this x right here. So let's divide both sides by 4. Okay, bring down the inequality, less than or equal to. And now my 4's cancel. So x is less than or equal to, and what's 0 divided by 4? 0. So which is greater, 1 or x? Well, x has to be less than or equal to 0. So it would seem to me that then the 1 would have to be greater. I'm going to say 1. Okay, so now write an equation or inequality that shows your answer. So again, we got to go back to which is greater, 1 or x. And we're going to say 1 is greater than x. Explain why your answer is correct. So again, we solved the inequality. We solved our third inequality and determined x is less than or equal to 0. Therefore, 1 would have to be greater than x. Okay, number 5. N is an integer. So we're back to our sets of numbers where you need to know like your set of integers, your set of natural numbers, your set of whole numbers, and so on. Okay, well, now the set of integers, let's take a look at what that looks like. N is an integer. Remember our birdie brackets for set notation? And n can be a negative number, 0, or a positive number. So most people write this like this. -2, -1, 0, 1, 2, and so on. And we go forever in both directions there. Okay, so that's n, an integer. So the question is, which is greater, n or the opposite of n? Oh, boy, we're going to have to do a little more processing here. So let's think about, well, what if n is less than 0? That means it's -1, -2, or -3. So if n is, let's just pick a number less than 0, like -1. Well, would the opposite of -1, how would that compare to -1? Well, the opposite of -1 is 1. And 1 is greater than -1. So the opposite of n would have to be greater than n. That's kind of complicated. Okay, so let's do this then. How about n equals 0? Well, if n equals 0, the opposite of 0, how does that compare to 0? Well, the opposite of 0 is 0. So they're equal if n equals 0. And then let's go n being greater than 0. And how about we just use this 1 right here? Okay, so how does the opposite of 1 compare to 1? Isn't the opposite of 1 or -1 less than 1? So it depends on which n we're using right here in the set of integers. It could be greater than, it could be equal, or it could be less than. So this is a situation, or if the relationship cannot be determined from the statement. Yeah, I don't know which is greater. This relationship cannot be determined. So write an equation or inequality that shows your answer. Well, I'm just going to say I couldn't come up with that. All right. I did do a few equations and inequalities down here, but again, the relationship cannot be determined. So explain why your answer is correct. Okay. Well, we checked for a negative integer, 0, or a positive integer, and we got a different answer each time. So we posted the trichotomy of integers. An integer can be negative, like -1, -2, -3, and so on. An integer can be 0, or an integer can be greater than 0, like 1, 2, 3, 4, and so on. So we posted the trichotomy of integers to determine we cannot tell which is greater. Frowny face. That's our first one we couldn't get. Okay, number 6 then. Statement, x is greater than y. Which is greater, x plus a or y plus a? Now this one we will be able to determine because I can take the given inequality, x is greater than y, and look at my expressions, x plus a or y plus a. How about we take this inequality and we add a to both sides? Now, bring down the inequality symbol, greater than, and on the left I have x plus a. On the right I have y plus a. And look at our statement, x plus a is greater than y plus a. So x plus a, you're the winner right there. Write an equation or inequality that shows your answer, and here it is right here. Good. Explain why your answer is correct. Well, all again we did is we took the given inequality and we added a to both sides. So we added a to both sides of the given inequality to determine x plus a is always greater than y plus a. Smiley face. Number 7. Now x is greater than y. Which is greater, x minus a or y minus a? Here's the same situation, you guys. Let's take the given statement and look at your expressions, x minus a, y minus a. So let's take that given statement, and this time let's subtract a from both sides. Bring down the inequality, and on the left we have x minus a, and on the right we have y minus a. And this is the statement, x minus a has to be greater than y minus a. So who's the winner? X minus a. Write an equation or inequality that shows your answer. There it is right there. So explain why your answer is correct. Well, again, we took the given inequality and we subtracted a from both sides to get the statement x minus a is greater than y minus a. We subtracted a from both sides of the given inequality to determine x minus a is greater than y minus a. Smiley face. Ooh, living the dream. Statement, 5 is greater than 4. Well, we all know that. Wow. So, which is greater, 5x or 4x? Now, if we make a statement 5 is greater than 4 and then ask you what's greater, 5 times x or 4 times x, a lot of people would say 5 times x. But to answer this, I'd have to know what x is. Right? And couldn't x be a positive number or 0 or a negative number? Which is going to change up, which is greater than the other one. So, let's do interval notation here. Okay, x is in, and x can be any real number. So remember our interval notation. This is the open interval from negative infinity to infinity. X is in the set of real numbers. So what does that mean? Or, hey, as a double inequality, we could write the same thing, and I want to write it both ways today. Wouldn't that be negative infinity is less than x, and x is less than infinity? Negative infinity is less than x, and x is less than infinity. So these two things mean the same thing right here. Interval notation and as an inequality right there. Now, look at what I did. Since x can be any real number, I made x less than 0, so x is negative. I made x equal to 0, or I made x greater than 0. Now let's find out what happens to our two expressions. So if x is negative, 5 times a negative number, like let's just pick a negative number like negative 1. 5 times negative 1 is negative 5. 5 times negative 1 is negative 4. Negative 5 is less than negative 4. And if x is 0, 5 times 0 is 0. And 4 times 0 is 0. 0 equals 0. And if x is greater than 0, like 1, 5 times 1 is 5, 4 times 1 is 4, 5x, or 5 times 1 is greater than 4 times 1. So, we can be less than, we can be equal, or greater than, depending on our value for x. Which means I feel a frowny face coming on. This relationship cannot be determined. Okay, so write an equation or inequality that shows your answer. Well, it couldn't be determined, but we did again use a lot of inequalities and equations down here to make sure we check that. All right, explain why your answer is correct. Okay, and again, we posted the trichotomy of real numbers to determine we cannot tell which is greater. Again, x less than 0, or x equals 0, or x greater than 0. That is all real numbers, and we call this a trichotomy because there's 3 situations there. Okay, awesome. Number 9. Oh no, 5 is greater than 4 again? Wasn't that the same one as the last one? Yeah, oh, we didn't like that. All right, well, let's see what we have here. Which is greater, 5 over x or 4 over x? Oh man, I have a feeling we're going to get the same scenario here. But let's prove it. Okay, so statement 5 is greater than 4. Which is greater? Well, again, it depends on my x's right there. You know what? I can't tell based on the x's. Now, this case, though, remember on the last one, x could be any real number. All right? Well, here, those x's right there, you all know you cannot divide by 0. So let me show you some very cool interval notation here for that. X is in the open interval, and this is called a union right here. And I'm giving you some advanced mathematics, but x can be any number but 0. So x is in negative infinity to 0, but that parenthesis tells me I can't reach the 0, union 0 to infinity. So this is a fancy way to say x cannot equal 0. It can be any other real number. All right? Now, let's put this on a graph, okay? So here's a number line right here. And let's think of all real numbers. So I'm going both directions. There's all my x's, negative, 0, and positive. But we have just made the statement we cannot divide by 0. So x cannot equal 0. So I put an open dot on the 0. All right. Now, let's play a second. So x can either be negative or positive. So if x is less than 0, that means x is negative. 5 divided by a negative number, how about we just use -1 again? 5 divided by -1 would be -5. 4 divided by -1 would be -4. And -5 is less than -4. Now the other possibility is x can be greater than 0. X cannot equal 0. So x is greater than 0. And let's do the same thing. So now let's pick an x that's greater than 0 and keep it simple. I'm going to use a 1. 5 divided by 1 is 5. 4 divided by 1 is 4. And 5 is greater than 4. So there we go. So in this scenario again, all right, it can be 5 over x might be less than 4 of x if x is negative. And 5 over x is greater than 4 over x is positive. So this is that frowny face again. This relationship cannot be determined. So there's no equation like for my inequality, but we did do a lot of that down here to get there. All right, and then explain why your answer is correct. Now remember, in this one, x can be less than 0 or x can be greater than 0. That's the dichotomy. There's two possibilities here. So with our restricted domain where x cannot equal 0, we posted the dichotomy of real numbers to determine we cannot tell which is greater. Wow. They're stretching you guys. Number 10. Okay, statement 0 is less than x and x is less than 10. That's a double inequality, and that's an open interval. And then 0 is less than y, and y is less than 12. Another double inequality with an open interval. Which is greater, x or y? Now, it may be easiest to see this if we graph both of these. So, I have two number lines right here. Now, if x is between 0 and 10, okay, here's what I do, all right? Open dot at 0 because x cannot equal 0. And then open dot over here at 10 because x cannot equal 10. Remember, x is greater than 0 and x is less than 10, meaning x is everything in between. And so this is a graph of 0 is less than x and x is less than 10 right there. Those are all the real numbers that will work for this double inequality. Now, those are my x's. Now, how about our y's? My left endpoint is 0. But I'm going to go open dot because y cannot equal 0. And my right endpoint now is 12. So open dot here because y cannot equal 12. But y is everything in between because 0 is less than y and y is less than 12. So those are all my y's. So then I ask you, which is greater, x or y? Well, it depends upon which x we use and which y you use, right? Because if x is 2 and y is 11, then x is less than y. But if x is 9 and y is 2, then x is greater than y. And what if x is 6 and y is 6? Then x equals y. This is another frowny face again. This relationship cannot be determined. Doesn't happen. And I didn't even use an inequality, but what I did use is two really good graphs right here. So explain why your answer is correct. If x and y are in the given open intervals, those are my given open intervals right here, then we cannot determine this relationship because there are infinitely many possibilities for x, there are infinitely many possibilities for y, and it just is going to depend on which x and which y we are using. Number 11. Oh my goodness, now they're doing this to us? 3 to the n plus 2 power is greater than or equal to 27? Oh, man. All right, we do this in pre-calculus. All right, now check it out, you guys. All right, this looks really scary, but we can do it. Let's take the statement. 3 to the n plus 2 power is greater than or equal to 27. Now, the left-hand side of this inequality is a base 3 number, 3 to some power. And the right-hand side is 27, but we can write 27 as a base 3 number. So I'm going to go 3 to the n plus 2. And do you guys agree that 3 times 3 times 3 is 27? And how do we write 3 times 3 times 3 as a power? That would be 3 to the third power. Now we have common bases on both sides. And if we make the statement that 3 to the n plus 2 is greater than or equal to 3 to the third, couldn't that only be true if this n plus 2 were greater than the 3? Look at that. Now, let's solve for n. So, see that plus 2? Let's subtract it. Bring down the inequality symbol, and n plus 2 minus 2 is n, and 3 minus 2 is 1. Which is greater, n or 1? Well, we just said n is, oh no, this is another frowny face, because n is greater than or equal to 1. But I don't know which one. This relationship cannot be determined. Okay, so write the inequality or equation that shows this. Well, I just know n is greater than or equal to 1 right there. Okay, so explain why your answer is correct. So what did we do? We took the given, and this is actually an exponential inequality right here. We took the given inequality and we solved for n. So we solved the given inequality and found n can be greater than 1 or n is equal to 1, but we don't know which. Oh, that's it. Are you kidding me? That's the last problem? I thought I had more. Okay, you guys. Well, I hope you enjoyed this as much as I did, and you have a great day. Get that ready, set, go for 4.4 done tonight, please.